Okay, now we're just going to have some little bits of vocabulary up here at the top. So, an event is the set of all outcomes that you are looking for. So like an event could be like if I roll a dice, or if I spin a spinner or something like that, or if I draw a card, that's an event. Okay, the sample space would be all the possible things that could happen. So like, okay, if I flipped a coin, that would be the event. The sample space would be heads or tails, so like the possible things that could happen. Okay, now probability, just in general, says measures the likelihood that an event will occur. Okay, probability of any event is always between 0 and 1. Now, if we write these in fraction form, that's true. If you have to write them as a percentage, then it's between 0% and 100%. So typically they'll either accept a fraction or a percentage. So you can write them in either format. And then right underneath there it says an impossible event has a probability of 0. So like, trying to think of an example. If I just had a normal die, like 1, 2, 3, 4, 5, 6, and I said, what's the probability I roll an 8? You would say 0. There's not 8 sides on that. So that would be a probability of 0. And then this says an event is certain to happen. So like, let's say I flipped a coin, and what's the probability I get heads or tails? That has to happen. One of those two things has to happen. If it has to happen, the probability is 1, or if you do it as a percentage, 100%. Okay, now we're going to do 3 types of probability today. So we're going to do theoretical, experimental, and then at the end we're going to do geometric. So I'm going to start with theoretical probability. Theoretical probability is basically what you think should happen. Just like in theory, on paper, like what should happen if I do something. Like if I flip a coin, theoretical probability I get heads would be like 50%, right? It should be that. That's what we should think that it would be. So that's your theoretical probability. So in terms of like how we calculate that, number of outcomes in the event that you want to happen, divide by the number of outcomes in the sample space. And then we're just going to go through a couple of these different formats for this question right here with the theoretical probability. So I'm just going to scooch this up just a tiny bit. Okay, so if I flip a coin, it's like a normal coin, nothing like not double-sided or whatever. There's a normal coin. Does anybody tell me what the sample space would be? Like, what are the possibilities if I flip a coin? Heads or tails. So there's your sample space. Heads or tails. I'm just going to write H or T. Okay, now there are, in this sample space, there are 2 possible outcomes, right? Heads or tails. So theoretically, what should happen? Oh, I forgot to put something. Let me go back up here real quick. If you guys see a P and then you see a parentheses, like I have right here, like this says probability of heads, probability of tails, that's what that means. This means probability of whatever's in the parentheses. Sorry, I don't know if everybody knows that notation, so that's my fault. So if you see P and then something in parentheses, it's probability of that happening. So what would you tell me the probability if I flipped a coin that I would get heads? 50, right? Okay, so if you want to do it as a fraction, it would be 1 of the sample space out of the 2 possible outcomes. So you can write it as a percentage or you can write it as a fraction, either one. This would be 50%. Okay, what would be the probability I would get tails? Same, right? 1 out of the 2 possible outcomes, you could do 50%. If you want to, I would even take, if you want to put the decimal, if you want to put like 0.5, any of those are fine. So any of those are fine. Decimal, if it doesn't tell you, decimal, percentage, or fraction. Okay, now, what if I rolled a die, like just normal dice? Like, what are all the possible things I could do if I rolled a die? Or possible outcomes I could get? Like in a game, if you rolled a dice. 1 through 6. So your sample space, you'd have 1, 2, 3, 4, 5, 6. Those are all the possible things I can roll. Just a normal die. All right, now, what would be the probability, theoretically, what should happen? If I roll a die, what's the probability I would get a 1? 1, 6, exactly. All right, now this one's kind of tricky. What would it be to not get 6? Yes, because it would be everything else. So it'd be like 1, 2, 3, 4, 5. You would just add those up. There would be 5 possible outcomes that would fit that probability out of the 6 total. What would you tell me the probability I rolled an odd number would be? 1/2. It would be 1/2. So if you look at this, your odd number is 1, 3, 5. So I'm just going to write this real quick. It'd be 3 out of 6, which would reduce to 1/2. So sometimes you might be able to reduce these fractions. Does anybody have any questions so far? Okay, now these are two, like, don't look at this for a second. Just look on the side of this line. Okay, it says you have 3 true-false questions, and you're going to answer them randomly. What is the sample space? Okay, this is kind of weird, but I'm just going to write out all the possible ways that could happen, and there's several of them. Okay, so I could just do like true, true, true. I could do like true, true, false. Each one of these would be different. We could do true, false, true, and we could do true, false, false. So those are all the possible ways if I started with true. If I started with false, we could say all 3 of them were false. I could do the first 2 false and the last one true. I could do false, true, false, and I could do false, true, true. So that's all the possible things if you just randomly answer these questions. So there's 8 total ways that that could happen. And if you guys actually remember from yesterday, from the multiplication counting principle, or the fundamental counting principle, sometimes it's called multiplication counting principle. For my first question, right, true or false, I have 2 choices. For my second question, true or false, I have 2 choices. And for my third question, true or false, I have 2 choices. If you do 2 times 2 times 2, that will give you 8. So there should be 8 choices. That's a little review from yesterday. Anywho, I wrote them all out for us. What is the probability that you guess all 3 of the questions correctly? Yeah. How many of these options are correct? Like if you had an answer key, because none of them match, right? Just one of them could be right. Yeah, you were on the right track. But so the only one of these could be right. So I don't have an answer key for it or whatever, but only one of these would be the correct answer. So it'd be 1/8. Okay, and then I've got this one on the other side of that line. This is a spinner, and forgive, it's kind of, a couple of the numbers look kind of faded on here. They're in color on my file, but they didn't print out that way, obviously. Now, this is weird in terms of writing the sample space. So you might think, if you look at this spinner, right, you only see the numbers 1, 2, 3, and 5, right? But when you write the sample space, that's all the possible outcomes. So if you were writing the sample space, you would actually have to write 1 3 times, because I see that 3 times. You would have to write, let's see, I have 2 2s, I have 2 3s, and I have a 5. So on that spinner, if you're looking around that, you actually have 8 different, like equally spaced things there. Now, this is a little trickier. So what is the probability that if I just randomly spun this, we would land on a 1? Yes, because you have 3 1s, so that's what I'm looking for. I'm looking for a roll into 1. I have 3 of those out of the total 8. What would you tell me your probability of spinning a 2 or a 3? 4/8, like 2 2s, 2 3s, so it'd be 4/8, and you can reduce that if you can, to 1/2. What is the probability I would spin and get a 6? None. There's no 6 on there, so that's impossible, so the probability there would be 0. Does anybody have a question? Okay. That's theoretical, what you think should happen. Now we're going to talk about experimental probability. Okay, experimental probability. Either you have to perform some kind of experiment or somebody has already done an experiment and you have the data from that. So this just says you perform some type of experiment or you collect data or you're given data. Now, the probability of the event here is the number of times the event occurred while you're doing these trials or from the data that you're given divided by the number of trials. So just to make this hopefully make a little bit more sense, if I flipped a coin, my theoretical probability, right, we already talked about this, it would be 1/2 for heads, 1/2 for tails. My experimental probability, it'll tell you at the bottom of the page here, here's this little experiment. It just says a coin is flipped 10 times, and then it tells you get heads 7 times, tails 3 times. So based on the experiment, what would the probability of heads be? 70%, just the 7 out of 10. Now, theoretically, it should be 5 out of 10, right? But that's not what happened in this experiment. So that's all you're doing. If they give you some data, just base it on the data, not what you think should happen. That's theoretical. If you have an experiment, base it on that. So then they got tails. We would think it should be 5 out of 10, but when they actually did it, they only got 3 out of 10. So that's the experimental probability. Is anybody having a question? Now, we're not going to perform an experiment here. We've just got like a little table that has the results of a survey. So this says, teacher conducted a survey to collect the eye colors of all his students, and then the table's going to show the results. So basically, we're not really performing an experiment. We're just asking everybody their eye color in this guy's classes. So first thing I would do, just really quick, I want to figure out how many total people that he asked. So I'm just going to take, we had 12 people with blue eyes, 58 brown, 2 with green, and 8 with hazel. So I'm literally just adding those up so I can get the total number of people. The total number of people would equate to the total number of trials, if that makes sense. So there's 80 kids in this guy's classes. Okay. How would you figure out the experimental probability here if I randomly selected one of these kids that they have blue eyes? Would you? Yeah, that's it. 12 over 80. And I'm being lazy this morning. I know that reduces, so I'm going to do my math enter here. So, or you can use your fraction key. So it'd be 3 over 20. So make sure if you can reduce the fraction, you want to reduce it. If you do want to write it as a decimal, let me just do that here too. I'll just grab a different color real quick. If you want to write that as a decimal, I am fine with that. That'd be 0.15. It doesn't tell you in the question what to write your probability as. So fraction would be acceptable, decimal would be acceptable, percentage would be acceptable. All right, what would you tell me for probability? I randomly pick one of these people and they have brown eyes. 58, yeah. You got 58 people with brown eyes over 80. Let me see what that is. Okay, if you reduce that fraction, you are going to get 29 over 40. Now, as a decimal, I'm going to go 3 decimal places. This is 0.725 if you want to write the decimal. If you like the percent better, we would just scooch that decimal over 2 spots. So it'd be 72.5%. So most of the people, and that's true just in general, but it's more common to have brown eyes. So way, way, way more people have brown eyes. What's the probability a person has green eyes? 2 out of 80, right? There's only 2 people with green. So this would reduce to 1 over 40. And I don't know what that is off the top of my head as a fraction, or I mean as a decimal. Okay, now as a decimal, this is really small. 0.025 as a decimal. If you scooch the decimal over 2 spots to do the percentage there, it would be 2.5%. All right, and then hazel, real quick, that's the last one in the table. We'd have 8 out of 80, which would be 1/10, which would be 0.1 as a decimal, or 10% of the people. So any of those, you don't have to write all 3 of those options. I'm just giving you options if the question doesn't specify how they want you to write the answer. Okay, how would you figure out if we randomly picked a person, they had blue or green eyes? What do you think? Exactly. Okay, so you got 12 people with blue, 2 people with green, you'd add them up. So the number of outcomes that we would like to possibly have here would be 14 out of 80. And then that's going to be 7 over 40. If you want to do that, let me figure out what it is as a decimal. As a decimal, this is 0.175 or 17.5%. Any of those are totally fine. All right, this one's a little weird. How would I figure out the probability the person I pick is not green or hazel eyes? Like, how would you do that? Not green or hazel. Riley, what do you think? Yeah, okay, there's 2 ways you could do it, and he said both. Okay, we could, so basically if we're not green or hazel, we're trying to figure out blue and brown. So we could add these together, or we could subtract these 2. It's totally up to you, however you want to do it. So green and hazel together is 10. So there's only 10 kids that don't have that. So all the people that don't have green or hazel, this should be 70 out of 80, which would be 7/8 to reduce that. And, excuse me, this is 0.875. If you like the decimal, that'd be 87.5% as a percentage. Does anybody having a question? Okay, my other question here, this is sort of along the same lines. This would be basically like data that you have collected, and it's just represented with a Venn diagram. So if you haven't seen something like this before, it's just 2 circles, little overlap in the middle, and then I've got this little number on the outside here. Okay, so it says all the members of the club were asked if they eat apples, that's the A, the circle on the left side, or bananas, B, that's the circle on the right side. Results are displayed in the Venn diagram. Okay, now do you guys know how to read these? All right, I just want to write, like, so the 17 people like apples, 20 people like bananas. What is the 52 in between? This is people who like both. What is this random 41 in the corner? They don't like either one, so they don't like apples or bananas. Okay, how would you figure out how many people have been surveyed here based on this Venn diagram? Like, what would you use with the numbers there? Like, how would I figure out how many total people this is? But what would you add up? Okay, why wouldn't we add 52 another time? It's like, is it 52 in both of these? You're right, what you said. No, some people do that. Some people do that on accident. They add these two, and then add it up. Okay, so the 52's in both. So you just straight up add the 4 numbers, don't add another 52. That's a little mistake I see people make sometimes. So I'm just adding these guys. Sorry, I'm being really lazy today. Should be 130 people if you add that together. Okay. Now, if I'm doing a probability here then, if I ask you probability, total number of people is 130. So 130 should be on the bottom. So what is the probability I randomly select somebody from this group and they eat apples and bananas? How would you set that up? The 52 would go on the top, exactly. All right, let me see. I know I can reduce that. So this is, oh, it's actually 2/5. So as a decimal, be 0.4, or if you want to do a fraction or a percentage, is 40%. Okay, how would you? This is kind of tricky. How would you determine the number of people if I randomly selected out of this 130? How many people eat bananas? How would you figure out the probability there? What do you think? Exactly. So you just 52, 70, because these people eat both, and these people strictly eat bananas. So 52 and 20 would be 72. Let's see if this is a decent number. It's definitely not. It does reduce. I got 36 over 45 as a fraction. As a decimal, I'm going to put this on the screen so you guys can see it. This is kind of a garbage decimal. So let me just write 3 decimal places. I'm going to do 0.554, and then as a percentage, it'd be 55.4%. Does anybody have any questions? Okay. The very last thing is geometric probability. Now, geometric probability, when you do this, a lot of the times these will have like a dartboard or something like that for you to look at, or it might be a spinner or something to that effect. Geometric probability is going to be the area of the event that you want divided by the total area. And that event can change based on what kind of a picture you're being given. But in this case, we're going to look at a dartboard for our example here. Okay, now let me scooch this up. Just to remind you guys, because this is dealing with a circle, so if you forget this from geometry, I'm just putting this here. Area of a circle is pi r squared. And these questions, it's going to ask you to leave your answer in terms of pi. So we're not actually going to multiply by pi. It'll make the answers look a little bit nicer. And it's kind of a complicated looking little dartboard here. So the first thing I want to do is find the area of the whole thing, because that would be going on the bottom of any fraction we're going to use for a probability. Can you look at that diagram? Just take a second here. You got 20 points if you hit the bullseye. That's the shaded region. You've got the ring right after that is 10 points. After that, 5 points. Outside ring is 2 points. And the distance here, each of these exterior rings has basically like that little distance is 2. So that's kind of in there. Can you guys tell what the radius of the entire circle would be? Okay, she says 9, right? This is 3. Then you go 2, 2, 2, right? So I'm just adding these up. So the radius of the whole thing would be 9. So if I'm doing my area, it's just pi times my radius squared. We're going to leave these in terms of pi. It'll make it a lot easier to deal with, I promise, for some of these probabilities. So 81 pi is going to be the area of the whole thing. Okay, now find the probability I would land in the bullseye. That's the 20-point area, right? So how would you find the area of the 20-point region? Because if I want to do geometric probability, it's the area of what I want divided by the area of the whole thing. So I know when I do this probability, on the bottom of this fraction, I got to have 81 pi. I just got to figure out what the area of the event I want is. So if I have my event being that I land in this 20-point region, how would you find that area? Yeah. What would you use as your radius? There you go. Radius of that little inner circle is 3, so it would be pi times 3 squared. So it would be 9 pi. That's the area of what I want. So then that I would just put on the top of the area of the whole thing. Now the reason I'm going to have you guys leave these in terms of pi is because what's going to happen here, the pi cancels out on the top and the bottom. Okay, now if you want to write this in one step, you can, but I'm just going to do 2 separate steps. This is 9 over 81 then when I cancel the pi's, and you can further reduce that fraction because both of those are divisible by 9. So my probability there would be 1/9. But that's why I'm going to have you leave it in terms of pi. Okay, now this is extremely tricky to do this last part. I'm going to see if I can grab a highlighter here. Okay, this is the probability you land in the 5-point region, which would be here, right? Or the 10-point region. So I'm actually going to color both of these real quick. So the 5, oh no, I'm not going to color that. Fired. Okay, hold on. I did the 5 and the 2. Shoot. Okay, we're going to do this area. Like these 2 rings. But it would not include that bullseye in the center. I'm just going to hold my finger there for a second so you can pretend I didn't start to color in the wrong ring here. Okay. This is the tricky part. Any idea how you would find the area of that shaded region? Because it would not include this guy in the middle. How could I find the area of just what I colored and I'm covering up with my finger the rest of it. How could I find the area of that like pink highlighted area? What do you think?
Can you find the radius of like the 5, 10, and the 20?
Perfect. Okay. So I'm going to pretend that this middle part's part of it. I'm just going to go out here. The radius would be 3, 2, 2. So the radius just for that 5 and 10 part, the radius would be 7. Okay, so we would just do pi times 7 squared. It's going to give you 49 pi. Now, I don't want to include the bullseye, right? So I'm going to subtract, which we just did in the last part of the question, the 9 pi. This is also why I want you to leave it in terms of pi, because these are like terms. We can just subtract them. So just this part that I have shaded in pink would have an area of 40 pi. Now, the actual probability then, the area of what I want is the 40 pi, and then the area of that whole dartboard was 81 pi. You can cancel the pi's here, but beyond that, the 40 over 81, that doesn't reduce. So just that would be my probability, the 40 over 81. And you guys can just leave it like that, or if you want to do the decimal or percentage, that's totally fine too.